First off, we need to define the task we want the model to perform. We might want our model to perform a classification task, that is, categorize input data into predefined classes or labels. For example, recognizing whether a picture contains a dog or not. This would be a binary classification task, predicting one of two classes, dog or not dog. For this, we set up our network with a single output node whose value would be squished between 0 and 1 using, for example, a sigmoid activation. And this value will represent the probability that the input image represents a dog. If we had multiple classes, we'd set up the output layer of our network to have one output value per class. The raw output values of the last layer in this case are typically called logits, and then would be passed through a function such as the softmax activation, which takes a vector of raw scores and transforms them into probabilities that sum up to 1. So our network would return the probability of the input belonging to each of the classes. Another task we might want our model to perform is a regression, where the goal is to predict a continuous numerical output based on the input feature. Unlike a classification task, which aims to categorize inputs into discrete classes or labels, regression aims to map input data to a continuous output. Let's say we want to predict the price of a house based on its square footage. Now, we input the square footage into the network, and the output would be a continuous value representing the predicted price. Thank you for watching this quick take from LLM Chronicles. If you enjoyed this snippet and want to dive deeper into the world of deep learning and large language models, just check the full episode in the description below. Don't forget to like and subscribe to support the channel and get notified of all new content.